information will change at the time of the day, of course. Under heavy load, we can, the good point of the cloud is that you can allocate additional VMs to manage the peaks. And so this is the main point where we need to extend the Palladio component model. And so actually we are going to develop two main tools. The Spaceport Cloud is under development at Polytechnico, and actually this will be used to support the performance and cost evaluation of the cloud. And in the future version, we are ready with the performance assessment. With the future version, we will be able to determine also the solution of multiple cost that provides quality service guarantees to the end users. And the other main component is the line tool that has been presented by Juan yesterday. And actually, it is an advanced, scalable engine for evaluating layered Q network models. And this is pretty advanced because allows to determine average values, but also percentile distribution, for example. And so the first things that we did was an analysis of the cloud solution in a way to determine a model of cloud resources and the cost. And actually, for the cost, these are the example of the pricing model only for Amazon EC2. So you can see that there is a huge offer from the cloud provider. It's not easy really to manage all of this information. Then what we did was also to provide a meta model for the cloud resources. So here there are some examples. Here you have a representation of the general concept of platform as a service, infrastructure as a services, and so on and so forth. Here you have some concepts that are specific for IaaS and specific for PaaS. And then here there are some concepts that are specific for the service level management and for the autoscaling of the cloud system. Then what we did is, so here this work was done at the CPI level, and then we can specify, we can map really the offer of many cloud providers with a one-to-one mapping to CPISM level. So here is the example of how we map the CPI concept to Amazon actually. I'm not able to manage this. To Amazon EC2. And actually what we have considered so far is Amazon, is Azure, is Google App Engine, and also FlexiScale, which is our partner. And so these are the example of how we map this information. So basically is we designed this application as CPIM, and we have this CPIM concept, and then we map this concept to Palladio component model representation. This is pretty easy because there is almost a one-to-one mapping to the concept of resources. Okay. Then, which are the 9 advanced features that we're developing, that our community are developing? Actually, the most important concept is the random environment one, which is a stochastic model based on Markov chain that is able to model actually the exogenous variability of the cloud system. This kind of model has been used, for example, also for modeling the frequency scaling of servers. For example, the CPU really can change the speed according to some energy saving decisions that are managed by the operating system and that are independent of the current state of the application. So actually here we can easily model, for example, some fast slow behavior of the cloud system that is properly able to work investigating. But this concept should be able to map this fast and slow behavior of the cloud system that I showed you in the very beginning of the presentation. And then we are also working on some demand distribution that are not currently supported by Palladio. Actually, Palladio allows to provide some distribution for the service demand, but in this case, Palladio can just run simulation, and the blending algorithm that is used to model to solve this kind of system is 2 orders of magnitude faster than the standard simulation. So this is promising also because on top of this, again, this is just for the performance assessment, but since we are designing a local search algorithm that is able to determine the best configuration of multiple clouds, we need to run several performance evaluation for a given design project, and Of course, we cannot rely on simulation because the time would be too high. So here I will just show you some example of the results that you can use with our tool. How much time do we have?
You have
5?
no, tell me.
7, okay. So actually here I will show you an example for performance and cost assessment of the spec web application again by considering the spec web application deployed on Amazon EC2 and on Flexi scale. So what we did, we choose some senior VM in the chip cloud provider. We have considered their speed, and we have also considered some realistic order profile. This trace was obtained by Polytechnical website, and this data over 5 years of data. So this is the worker profile that we have to consider. So we have these two, this bimodal distribution of the number of users. It's common. And then we have decided an allocation profile that this is provided by the designer, but again, this will be the result of the design time exploration and optimization. So according to this allocation, what we can do is running SpecCloud and line, we can estimate the response time, the average response time, for example, for the login pages and for the other pages of the application. So the account summary page, this is a banking application, so an important page is the account banking summary that shows the situation of a banking account to the end user. So we are able to determine this average response time. And what we get from here is that Amazon performance are better, but if we consider the cost, actually the Flexi scale is a little bit cheaper than Amazon. So this is the cost per hour to run the application. And then we can also have a comparison of the performance. So actually, at the end, the result was that the Flexi solution is cheaper and but suffers a little bit in performance if compared to Amazon. So in this way, however, the quality of service engineer has some tools to evaluate the trade-off of different solutions. So this is too much lineup. This is the summary of the presentation. So what we are doing is really developing this kind of tool for the quality of service assessments. The ongoing work is focusing on the estimation of the availability metrics and also in the development of this local search for design time space exploration. And another task is so this is for design time management, but according to the performance that we get, we think that we can move this kind of solution both for the performance model and for design time exploration, also for the runtime management of applications. So that's, yeah, any question?
What machines did you evaluate on Amazon?
Actually, the deployment is run the clients and the backend. We use extra large VMs, while the web server, which is the system under test, is the medium. And this is because we fine-tune really the configuration of the web server application in a way that we can optimize the performance. And we have considered similar resources also in Flexi scale offer.
What would actually prevent you on my private pod? Are there resources that are not present and machines that are not
actually, we are not considering hybrid solution. We are just considering the cost for use of resources. So in that case, you should adapt our solution according to.
I mean, can you add any additional attributes? I mean, with some kind of cost function?
No, not really, because it's not in the focus of MODACloud to have a hybrid solution. So this is for the cost. So actually, if you have.
Also, the project is just on the public cloud provider.
Yeah.
Okay.
Yeah. So actually, if you want to use for these, you should count the number of users that you think you are able to host in the private, and you just consider the shape for the public. If we have room in the project timeline, probably consider also this.
So what's the primary value of model in your approach to this project?
Actually, the good point is also a separation of expertise, because the software engineer is focused on the functional design, while the quality service engineer, which is an which has knowledge with the skeletal performance model, can do this functional analysis. The nice thing is we can also have several engines according to the quality metrics of interest, and we can really use the best engine that fit the analysis.
So, to some extent, the model would mirror